All right, this is our last example. An electric grill that uses 1600 watts of electricity is plugged into the circuit described in example 3. It says, write and solve an inequality that represents how many watts you can actually add to the circuit without overloading it. Without overloading it means it needs to be less than that particular amount, all right? And it says a grill uses 1600 watts of electricity. Let's see what they came up with right here. So it kind of takes that previous example and it wants you to write an inequality that says how many more watts can you actually have. If we know we're using 1600 watts of power, watts is just a measurement of power, and microwaves and toasters and like Keurigs, heating elements tend to use a lot more of the wattage out of your circuit. And so if we want to stay under 1800, it's not less than or equal to, but just less than, and we could say how much more can we have? It says right here W would be less than 200. Can you, because you would solve it, you would subtract, and you know that would be 200. So you can say that you can add up to 200 more watts. That's like maybe 2 or 3 light bulbs into your circuit. In addition to the electric grill, which of the appliances listed in the table in example 3 can you plug into the circuit at the same time without overloading the circuit? So apparently there's a table that we don't actually have, so this example is not the best one to go over because there's more information than we needed, but we kind of get the idea. If it says we want to not go over 1800, if it that's in the previous example that in example 3 apparently. Yeah, anyway. And so there must be a list of items that you can actually plug in and stay under your 200. Circuits are kind of cool that way with, we draw circuits like this, and here would be like a power source, and here we represent like a radio or a light bulb or something. Sometimes we draw a circle around it to represent the light bulb, and the current would flow, current flows through it like this, and as it goes into a source like a light bulb, the current will pass through it, but the voltage will end up dropping, and it flows a lot like water. It goes through the circuit. Anyway, a little more to discuss with physics. There's all sorts of equations that you could use when it comes to physics and electricity.